Hello and welcome to our next video on statistics. We will learn about quartiles and interquartile range and how to find these measures by doing the linear interpolation. So there are three types of quartiles. The lower quartile, Q1, which is positioned at 1/4 of the ordered data, the upper quartile, Q3, which is positioned at 3/4, and the median, which is sometimes called Q2, the second quartile, which is in the middle. And the interquartile range, IQR, is the difference between the upper quartile, Q3, and the lower quartile, Q1. There are two types of calculations. One is for the discrete data, and we usually do it using the calculator. And we will learn how to do it on the next slide. And then when the data are given as continuous, we have to use the method called the linear interpolation, and the most of this video is actually about how to do the linear interpolation starting from example 2. But let's first learn how to do it for the discrete data. So there are 10 data for the wind speed, and we will now find the quartiles using the calculator. And we need to enter the data, so pressing statistics, okay, one variable, okay, 7, okay, 7, okay. You can pause the video, enter the data, and then continue watching. Okay, so here are the data. Now we press OK again, and for the one variable results, press OK, scrolling down, and we can see that the upper quartile, lower quartile is 9, upper quartile is 17, and the median is 11. And so the results, as we saw, are Q1 was 9, Q2 11, Q3 17, and the interquartile range is 8. So let's look at the linear interpolation. So here in this table are waiting times in a local surgery, and we are asked to find the interquartile range. The first step is always to find the total. So here we've got 15 people, and there are 4 steps how we find the interquartile range. Let's first find Q1. So in the first step, we always have to find exactly the position of 1/4 of the data. 1/4 of 15 is 3.75. So we need to find where in this data is 3.75 value. In the second step, we need to find the class and the position inside of the class, because we are looking for the 3.75th person. And there are 2 people in the first class. The third 0.75th must be in the second class. So to find the position inside of the class, we always take away all the previous people. So if we do 3.75, take away 2, because in the first class there were 2 people, it's 1.75th person in the second class, and we call this the position P. In the next step, we need to find the class width. So 4 minus 2 is 2, and to calculate the step, we just divide this class into 5 people, width by the frequency, and the step is 0.4. So finally, to calculate the lower quartile, we can use this simple formula. We start from the lower class boundary, and then we multiply the step by the position inside of this interval. And if we do it, we'll get for Q1 2.7 seconds. To find Q3, it's very similar 4 steps. First, we find 3/4 of the data. 3/4 of 11 is 3/4 of 15 is 11.25. In the second step, we have to find now the correct class and the position. So the 11th person will be in the 4th class, because in the first 3 classes there is 11 people. So if we do 11.25, take away 11, it's 0.25. So this person is in the 4th class. And now we can find the class widths. Again, 8 take away 6, the step, which is the width divided by frequency. There are 3 people, so the step is 2 over 3. And finally, to calculate the lower quartile, again using the formula lower class boundary plus position times steps, we get 6.17 seconds. So to calculate the interquartile range, we just take away the upper quartile minus the lower quartile, and we get 3.47 seconds. In some questions, we have to be careful about the class boundary. Like, for example, in this question here, where the weights of 20 rabbits were recorded, but as you can see here, the first class is finishing at 990, but the second class starts at 1000. So actually, there are some missing numbers in between the classes, and in this case, each class always starts in the midpoint between, so for example, the second class will start in the midpoint between 990 and 1000, and the end of this class will be between 1190, midpoint between 1190 and 1200. So let's have a look how to do it. To find Q1, again, we find 1/4 of 20, which is the fifth value. The fifth value is in the second class. So to find the position is we do 5 take away 3, so it's the second rabbit in the second class. The class width is, and now here we see that it finishes at 1195 and it starts at 995. So the width of this class is 200, step is 40, and so using the formula, we can calculate Q1, and we will get the answer 1080 grams. To find the upper quartile, you can do it on your own. You can just pause the video and use these 4 steps and try to find the upper quartile on your own. So let's now go through the answers. Again, so to find the total position is the 15th value. The 15th rabbit is in the third class. So to find the position, it's 15 minus 8 is 7. Class width is 200. Step is 25. And so the upper quartile of the rabbits, of the weights, is 1370 grams. And therefore, the interquartile range will be 290 grams of their weight. And finally, in the last question, you can pause the video and try to answer this question on your own. Try to find the interquartile range, and then we will go through the answers together. And here are the answers to our last question. So the total number of bus journeys was 30. The first quartile is 1/4 of 37 and 7.5 position, which is in the second class. It's 1.5 position in the second class. Step is 0.25 and Q1 was 11.88. The third quartile, 3/4 of 30 is 22.5, so this is the position in total. This is in the third class. It's 8.5 position in the third class. The width is 2, and Q3 is 15.05. So the answer for the interquartile range is 3.17 minutes. And that's the end of this video. I hope it was helpful. Thank you for watching.